Right, so it shows us the diagram of a triangle. The information it gives there is actually all drawn on the diagram. So the first thing is to show that the sine of angle ACB, which is this angle here, the sine of this angle is equal to 2/3. Now to do that, we're going to have to use the sine rule. And the sine rule tells us that the sine of an angle, so the sine, and we're trying to find angle ACB, the sine of an angle divided by the length opposite, so the side opposite the angle ACB is the length 4x, and this ratio is going to be the same whichever angle you're looking at on the triangle. So that's going to be equal to the sine of 30 degrees divided by the side opposite 30 degrees, which is the 3x. Okay, and then by rearranging that, we get sine of ACB equals sine of 30 times 4x over 3x. The x's cancel. Now, what's sine of 30? Well, you are allowed to use the calculator on this. If you put sine of 30 into the calculator, you will find that it equals a half. Now, if you didn't have a calculator, remember that by using a 60-degree equilateral triangle and drawing a perpendicular height on there, it's quite easy then using Pythagoras to see that the sine of 30 is a half. It's the same as the cos of 60. Remember that the sine of an angle is the same as the cos of 90 minus that angle. Anyway, that's another topic. So 1/2 times 4/3, obviously the 2 cancels with the 4 there, and we end up with 2/3 as required. Okay, now part B. Find given that ACB is obtuse, right? Find the size of angle ABC. Now, angle ABC is this angle here, and it tells us that ACB is obtuse, meaning, and obtuse of course means it's greater than 90 degrees. Now, let's just think about why they tell us that. If you remember what the graph of sine looks like, so if I just call that theta and that sine theta, then you should remember that it looks something like that. And at the top there, that's +1. At the bottom there, that's -1. That there is 180 degrees. That's 360, and that there is 90 degrees. Now, if we've got sine equals 2/3, 2/3 is about here. So if I draw a line across, you will notice that between 0 and 180, there are actually 2 possible angles that it could be. Right? There are 2 possible values of theta that will both give you sine theta as 2/3. So, and then one of those angles is going to be less than 90, or acute, and the other one of those angles is going to be greater than 90, or in other words, obtuse. So what we're going to have to do is work out first of all what angle ACB is. So what we have to do is say, right, angle ACB, and remember, to get from the sine to the angle, we're going to have to use arc sine or inverse sine of 2/3. And remember that -1 there, it's not really the same as a power, it denotes an inverse function. So it's the function that tells us what the angle is if we are given what the sine of the angle is. So, and on most calculators, I think they do it with a -1 sine, -1, meaning inverse sine. Also sometimes called arc sine. And I'll just try and find a calculator. And what we'll do is inverse sine of 2/3. Here we are, yes. So sine, inverse sine of 2 divide 3 equals 41.81. So 41.81 degrees. Now, but remember though, our angle that we want is obtuse. So if you think about the graph of sine, remember we've got two angles here which both have a sine equal to 2/3. Now the graph is symmetrical, so it means if one of the angles there is, I'll try and draw it in. If that there is 41.81, then it means the other one, because of the symmetry, is going to be 180 degrees minus 48.81. And that comes to 138.19 degrees. And so I'll write here ACB is 48.81, or it could also be 138.19 degrees. And in fact, because we know it's obtuse, that's the angle which we choose. Okay, so now we know that this angle is 138.19, and it's quite easy then to find angle ABC, because we just subtract the other two angles, 30 degrees and 138.19. We subtract those, of course, from 180. So I'll do that up here. Right. Okay, so part B, ABC equals 180 minus 30 minus 138.19. Okay, and that equals 11.81. 11.81 degrees, and we've done it to 2 decimal places as required. Okay. Now, part C. Given further that the area is 20, find the value of x to 2 decimal places. Right, to do this you need to know that the area of a triangle, as well as equaling half the base times the perpendicular height, is also equal to a half the product of any two sides. So I'll use the two sides that we've got, 4x and 3x, times the sine of the angle in between, and the angle in between is 11.81. Okay, now that is going to equal, what's that? It's 2 times 3 is 6, so it's going to equal yes, we know that equals 20, and we know that's going to be 6x squared times sine 11.81. So in other words, x squared is going to equal 10 divided by 11.81. 10 divided by 3 sine 11.81 degrees, and then we're going to have to square root that to find x. So I can do that on the calculator. Alright, here's the calculator, and what do we want? We want the square root of 10 divided by 3 sine 11.81 equals, and it comes to 4.04. 4.04, and they haven't given us any units, so we just have to leave it as that, 4.04. Okay, now let's continue. Right, so part D. Find the length of side AC. Right. Well, various ways you can do this. We can either use the sine rule again, or, I mean, we could use the cosine rule as well. They should both give us the same answer. I think it might be a little bit easier to use the sine rule. So remember, the sine rule tells us that the length of a side divided by the sine of the angle opposite. Now the angle opposite was angle ABC, which is 11.81. So we've got AC over sine 11.81 has got to equal, and we can choose either of the other two. I'll do the 3x divided by sine of 30. So AC is going to equal, now we know that x is 4.04 times sine 11.81 divided by sine of 30. Remember sine of 30 was a half, so that's the same as timesing the top by 2. So I can then use the calculator again, and we should get a value for AC. So it's going to be 2 times 3 times 4.04 times sine 11.81 equals, and we've got 4.96 equals 4.96, and we've given it to 2 decimal places as required.